So for no good reason, I'm going to do this twin entirely backwards. Why? Don't have a clue. That's what I'm going to do. Start with the bonuses here. And these are very similar to the bonuses on your quiz. And bonus 3 is a brutal bonus because these are all by hand approaches. It says don't use Y1, Y2. So to do bonus 3, the best technique that there is to literally ln both sides. So you take the natural log of 10 to the 3x minus 8, and you set it equal to the natural log. It might make sense to do a log, but actually, let me rephrase that. On this particular bonus, because there's a 10, the best approach is actually to log both sides. I've only taught ln both sides in class, but there's a reason log both sides makes some sense here, and I'll show you in just a second. It's a little easier than lning both sides. Now you have a property of logarithms. It says that the r can be shifted out front, so I can shift that up front. 3x minus 8 times, and I'm going to wrap that in parentheses right now because it is two things. The log of 10 is 4 minus x times the log of 3. Now, the reason I switched over to log is because log is base 10 if not declared otherwise, and log base 10 of 10 is 1 because it's what power of 10 creates a 10. So I can strike that out and have made the left-hand side so much easier. The right-hand side is still going to be the distributive property. 3x minus 8 would equal 4 logs of a 3 minus x logs of a 3. And now we're going to take anything with an x and we're going to shift it left. So 3x is on the left. We're going to say plus x logs of 3 is equal to 4 logs of 3 plus 8. So I know some of you guys haven't quite grasped this, but this is just a number. It's some decimal. So it was x's on the left, numbers on the right, and this was log of 3 times x. Now, the left-hand side, both of these pieces are in possession of an x, so I get to use my favorite F word, I get to factor. If I factor an x out of 3x, I have a 3. If I factor an x out of x logs 3, I have plus a log of 3, and that would be equal to 4 log 3 plus 8. Go through on the isolation step. And I have a perfectly good answer. Now, it would look better if I wrote 4 log 3 plus 8 over log 3 plus 3. And you'll notice I'm not doing any cancellations because there are none. There are 4 pieces to that fraction. They all don't possess an even number. They all don't possess log 3. That's as good as it gets. All right. This is supposed to be bonus 2. Bonus 2 is a factoring bonus. Not what I want to do. I need to save this, don't I? Just in case something happens, this is the Chapter 6 test twin. All right. Now, bonus 3 is a factoring problem. This is going to seem kind of funny here as to where I come up with these numbers here, but I'll try to explain them. To make a 25 to the x, it takes a 5 to the x and a 5 to the x. But because let's think about this. We do 5 to the x times 5 to the x. That is 5 to the 2x, which is a 5 squared to the x, which is a 25 to the x. Weird, huh? That's how exponents work. It'd be wonderful if you guys understood them, but we're just trying to survive, right? Now, to make a 12, your choices are probably something along the lines of 3 and 4. All right, so the outside now makes 4 times 5 to the... I have a mistake here on this problem that I need to fix. The outside makes 4 times 5 to the x, and the inside makes 3 times 5 to the x. So this needs to be changed. Let's just say minus 5 to the x. So plus 3 minus 4, because that would be a negative 5 to the x. And I need to fix that real quick, but hopefully I'll remember to do that. Anyways, I get to use my zero product property. So 5 to the x plus 3 is a 0, or 5 to the x is 4. All right. And sorry, this should be, I'm sorry, I am tired. 5 to the x minus 4 is a 0. If I add 4 to both sides, I've got something that might make some sense. I can do change of base, or I can do ln both sides, but 5 to the x is 4 says what power of x? 5 to what power creates a 4? It's going to be a decimal, right? Let's just ln both sides, or let's just do log. Log base 5 of 4 is my x. Fire up my trusty TI-84, which is not where it's supposed to be. There she is. Now, if I'm going to do log base 5 of 4, I'm going to have to do ln 4 over ln 5, right? And there's my answer, 0.8614. The next one is going to be nonsense. I don't know why I keep writing a 4. Shift that 3 over. And what you would be doing here would be doing log base 5 of negative 3 is x. And this is nonsense. Do you know why? You should, because we talked about domain of a logarithm. But say you don't know why. Let's see what the old TI-84 does. So ln of a negative 3 sitting pretty over ln of 5. Error, not real. It's not a real solution. So there's only one real answer. This one, the other one is not garbage. That's your only answer. All right, next one. Solve this one. And again, these are meant to be done by hand. So they're not as bad as they think, but it all depends on the kid and if they have any number sense whatsoever. This thing is ready to become an exponential. It's 5/3 raised to the x plus 5 equals 27/125. What a weird thing. So let's see if what I'm thinking makes any sense. That's what 27 over 125 is. It really is, because 27 over 125 is 3 cubed over 5 cubed. If I flip the exponents around, I would have 5 to the negative third over 3 to the negative third. And that's why that exponent's up there. So what I'm doing is I'm making the bases match. And I'm really demonstrating an understanding of exponential rules. So I'm really getting on up there as far as comprehension and just being able to do some higher level things. Now, because the bases match, x plus 5 must equal a negative 3. And then it's just as easy as peasy as subtracting 5. And there's my x value, negative 8. Looks like an intimidating little problem, and if you don't have number sense, it's impossible. But if you do possess number sense, it's very well doable, and it's really, really easy. I mean, it probably only took me just a few seconds to make that problem. So surely you guys can answer something that only takes me a few seconds to make. I think I spent about 30 seconds on it. Surely you guys can do that. I'm not that far above you. Or am I? I don't know. Anyways, something we probably shouldn't talk about in school. Weapons-grade plutonium has a half-life of 24,100 years. If 3,000 pounds of unused plutonium are put into deep storage, how long until there is only 10 pounds of weapons-grade plutonium left? Now, unless I specify, I really don't care if you do Y1, Y2. There are things on this test that you have to work out by hand. And like you have to show me that work. So it's okay if you use Y1, Y2 every once in a while because I want you to use it. Because if you do math in the real world, you're going to be using technology. We'll make you learn how to do everything by hand, but you do get to use technology. So anyways, it's mentioning half-life. Add the amount after time passes, the principal times 1/2 to the t over HL. HL for half-life. The principal is 3,000 pounds. The half-life of this weapons-grade plutonium is 24,100 years. And my goal is to get down to 10, and I'm just going to Y1, Y2 this thing. I'm not going to do a lick of math because I'm literally going to use technology to do it. We have a 10 in Y1. We got a 3,000, 1 over 2, with an exponent of x divided by 24,100. And I've got way too much other stuff in here. All right, that should be right now. All right, I'll do a zoom 6, but it's worthless. But you know that by now. I do see the 10, which is kind of cool. That showed up. That was nice. So when it comes to my window settings, if I have a half-life of 24,000 years, I'm probably going to want to look out pretty far. I'm going to go out 250,000 years. I have no idea what the answer is. I just made up some numbers and threw them on a piece of paper. I am going to adjust the Y-max up to 20 for no good reason. Actually, there is a good reason because it's more than 10. So this is 250,000 years in the future. And if I don't see anything, I'm going to add 250,000 more years to that problem. And I did see an answer, which is kind of cool, because that means that we halved about 10 times. 10 times 24,000, 240,000. So there was some reasoning behind my numbers. Anywho, second trace 5. Enter, enter, enter. And this one, I'm pretty sure I made multiple choice on your test. But if I didn't, it's just Y1, Y2. So 198,315 years, give or take a couple thousand. Because who knows if our numbers are right. I mean, it could be 24,102. Nobody knows. Well, we do know, but this is what we're telling y'all. So 198,315 years. Long, long time, right? Find all the factors of x cubed minus 4x squared plus 49x minus 196, given f of 4 is a 0, which, by the way, means that there is a factor of x minus 4. Because this is legit saying for the bajillionth time that x is 4. Speaking of x being 4, I can take that 4 and I can do good old synthetic division. The acronym here was DMA. I think most of my students have this, except for just a handful. We drop the 1, 4 times 1 is 4, negative 4 and 4 is 0, 4 times 0 is 0, 49 plus 0 is 49, and 4 times 49 is 196. Put a 0 there. You have a remainder, you have a constant, you have an x, you have an x squared. You can rewrite that as x squared plus 49 because there are 2 more zeros right there. You are going to set it equal to a 0. You are going to take away 49 from both sides. You are going to counteract squaring by square rooting. You know that the square root of a negative number is imaginary. So x is plus or minus 7i. So one of your factors was real. The other 2 are what we call complex factors, and they are x plus 7i and x minus 7i. And there are your 3 factors of said polynomial. You're welcome. Moving on to number 19, solve using change of base and the graphing ability of your TI-84. Cam, I hope you've got this figured out by now. I really, really do. I'm just calling out Cam. Arden, figure it out. Who else off the top of my head? I really can't think of anybody from first period. Most first period's good. There's a handful in fifth. My 6th period class, some of y'all need to be working on this. 7th period, I think y'all are in good shape. But anyways, I'm just calling out Cam for no good reason. I like ln. This would become 4ln of 4x plus 1. And if I like ln, you should like ln. Sitting pretty over the ln of 8 because your job is not to learn algebra 2. It's to think like I do. Equal to the ln of 2x plus 1. Sitting pretty over the ln of 6. And then add a 1. You have a Y1, you have a Y2, you go push buttons. That's what you do. All right, so let's see what kind of nightmare graph I created here when I made this problem up. I do remember I checked to make sure it had a solution. So that's all I can tell you. That's one thing y'all are probably not accustomed to. I make everything that you do. For some reason, I decided not to go to math num n over d. I just notice I'm careful about closing parentheses. Anyways, Zoom 6 it. Decent chance you won't actually see an intersection on these. Oh, there is one. Yeah. Okay. So no problems. Once my little circle's done, we're good. Second trace 5. I'm just going to get somewhere in the neighborhood, and I'm going to press enter 3 times because I'm in a hurry. There she is, 3.3721. Easy peasy, lemon squeezy. Moving backwards to 18, what yearly rate of interest is required to triple an investment in 9 years? This one is not multiple choice. I don't care how you do it. I don't care if you use technology or if you do it by hand. I really don't. Because you can see like 17 above this says, show me some work. There's a couple that we're about to get into that say, show me work. But if I'm going to triple an investment, and I talk about yearly rate, I don't have to use the compound interest formula. I can just use the formula for growth, that the amount after time passes is the principal times 1 plus r to the t. And I'm going to triple something. I would make the principal, but this is me, I would make the principal $1, which means that after time, it would become $3. So 3 equals 1 times 1 plus r to the t, and the t is not known, or sorry, the t is known to be 9. Now, this is a really, really easy problem to do by hand. We had this section. The opposite of the 9th power is legit. It's reciprocal 1/9. Okay? So 3 to the 1/9, these guys canceled, must be 1 plus r. We subtract 1. And if you know what you're doing with math, this is probably quicker than doing y equals. I know some of you don't believe me, but that's because you're slow. Anyways, 0.1298 or 12.98%. And again, I did not make this question multiple choice. It is a free response question. So if you could do this, and you can do this, you can do this. 3 and y1. I'm showing you this. I honestly hope a lot of you don't do this, but you know, I didn't specify, did I? Zoom 6. You'll see the intersection happen pretty quick because our answer is this teeny tiny little decimal, right? And there it is. Second trace. And this might seem to you like this was quicker. But that's because I was teaching. I wasn't doing. 0.1298. Same exact answer. Got it. Now 17 is 100% free response. You're supposed to do your work on the answer document, so I will be looking at it. Not multiple choice one bit whatsoever. I want to see the work. It's kind of like the one bonus I did. 500, and this one is harder than the one on the test. I promise you, it is harder than the one on the test. Because the one on the test, this is the issue. Anyways, 1/5 is 5 to the negative first. So 5 cubed equals 5 to the negative first. Keep your current exponential space of 4x minus 3. And then we can drop the bases, right? So 3 equals negative 4x plus a 3. I get to subtract 3. That makes a 0. And I did a whole bunch of work. I don't know why I just divided by x. I did a whole bunch of work to get 0, because 0 divided by anything with the exception of 0 is 0. It is what it is, man. Anyways, moving backwards, I'm on 16 now. You're supposed to solve by exponentiating, and you have to show your work. You have been trained for the last 6 months to do the easy stuff first, so 10 plus 5 is 15. Now we're going to divide that 5 out. So a log base 5 argument 2x minus 1 is equal to a 3. And now you're going to do the process of exponentiating. Remember, log is bay. So I have a base of 5. It gets raised to the third power and it equals 2x minus 1. If you don't know what 5 cubed is, man, are you even trying? How do you breathe? Like, be glad that's an autonomous function. So I'm going to add 1 to both sides. That'll give me 126. I'm going to cut that thing in half. 126 cut in half is 63. And I'm moving backwards again to 15. Solve 3e to the 4x minus 2 minus 3 is 12 by converting into a logarithm. And again, it's one of those I have to see your work. I'm going to add 3 to both sides because Milbrath says do easy stuff first. But what do I know? I'm just a math teacher. So 12 plus 3 is 15. Divide that 3 out. E to the 4x minus a 3 must be a 5 because 15 over 3 is 5. And now we're going to change to a logarithm. We have isolated the base. We are going to change to a log. She is a log base E. Her argument is 5, and she equals 4x minus 3. Remember to understand the understood log base E is ln. Easy thing to do here is add 3. That would make us equal to 4x. Divide by that 4. There you go. 15's done. Moving backwards, 14, solved by taking the ln of both sides. Oh, by the way, notice on this one, I said or ln both sides, which is harder to do on this one because the exponent having 2 parts. Actually, this one's not true. That's an E problem. Need to throw that out. But anyways, just isolate the log, isolate and convert to a log. Solve by lning both sides because that is a valid technique and I want you to be aware of it and I want you to know it. So, easy stuff first. Add 10. 25 is 50 times 4 to the x. Divide out the 50. 25 over 50 has always been a half, and it equals 4 to the x. I don't need logarithms to do this one. I already know the answer. Do you? All right, well anyways, if you don't know the answer, log is bay. Oh, I want you to ln both sides, don't I? So the ln of a half is equal to the ln of 4 to the x. Exponents get brought to the front. That's a property of logarithms. I know you don't like properties. They're actually called laws. For some reason I call them properties, but they're laws of logarithms. And to isolate this x, I am simply going to divide through by the natural log of 4. And I'm about to get a number. So I have ln of a half divided by the natural log of 4. And I was right. It was negative 1/2. So x is negative 1/2. You know, I knew that. I didn't say what it was, but this is how I knew it. Because 4 to the negative 1/2 is 1 over 4 to the 1/2, which is 1 over the square root of 4, which is a half. All right, moving backwards again, moving to 13. We're supposed to find f of g of x, more affectionately written f of g of x, and g of x happens to be 3 of x minus 4. So I'm actually finding f of 3x minus 4, which means I take that crap and I stick it right there. 3x minus 4 quantity squared minus a 5. And I believe if old Jesus saw 3x minus 4 squared, he would write it twice and he would foil the devil's plans. So 3x times 3x is 9x squared. 3x times negative 4 is minus 12x. Negative 4 times 3x is minus 12x. Negative 4 times 4 is plus 16. And then there's that minus 5. Don't forget about that guy. combine like terms, 9x squared minus 24x plus 9. I wonder how long I've been at this. Hasn't been too long, but it's a pretty long little thing. I did those bonuses, which took some times. What do we have here? We have a problem about Smellyville. So Smellyville is decaying at a rate of 24% every 3 years. If the current population is 25,000 Smellvillians, write a model for Smellyville. So the amount after time passes is the principal times 1 minus r, because it is decaying to the t over this time period. That's your model, okay? If you see that that's the kicker right there. So the amount after time passes is the principal of 25,000 times 1 minus, I don't really feel like showing this. This is 0.24. 1 minus 0.24 is 0.76. 0.76 to the t over 3, because it happens every 3 years. Convert your smelly 3-year model into a smelly yearly model. So what we're going to do is we're going to take that 1/3 and we're going to move it inside, leave the t on the outside. We're going to find the cubic root of 0.76. I'm going to get 0.9126. And now she is a yearly model. Still smells. To find the annual decay rate, notice how these two pieces are lining up perfectly. 1 minus r is 0.9126. If you shift your r right and your number left, you'll have it 1 minus 0.9126 is r. And that is going to be 0.0874. Or 8.74% per year. Smellyville is declining pretty quick. When will there be just one smelly person left in Smellyville? So use this model. 1 equals 25,000 times 0.76 to the t over 3, and then do y1, y2. 5 smelly people in y1. No, 1 smelly person in y1. And then we have all 25,000 of them, but that is attached to the decaying. That is x over 3, right? Leap. Now, it's not going to take Smellyville too long to disappear. I mean, the town smells. I'm going to restore my window back to room 6. And I don't feel like looking out more than 100 years, because the town's shrinking pretty quick. So window. All right, there we go. Window. I'm pretty sure it's going to happen within 50. The town stinks. Probably happens a lot quicker than that. Probably within 30 or 40. I don't know. Let's see. That was 100 years. Oh, wow. Smellyville lasted a lot longer than I thought. Okay, let's go out 200. People just, well, what happens is you get accustomed to the smell. Nobody outside of Smellyville would know that they smelled. Now, would they? Second trace. 5. Enter. So the calculator gave me 110.69903. 110.69903. Let me make sure I got all of that. 69903. All right, so cool. I have 110 full years. I got this decimal here, 0.69903 of a year. And I'm going to multiply that by 365 to become days, 255. 255. I should probably actually do 365.25, but 0.14, maybe you understand why I'm saying that. Taking the decimal, this is days, multiply it by 24, and I get hours, 3 hours. See, let's take away my 3. This is in hours. To convert it to minutes, I multiply it by 60. 30 minutes. I take away the whole minutes, and I'm going to convert that 168,000th of a minute into seconds by multiplying by 60, and there we go, 10 seconds. At that point in time, there will just be one little smelly, well, yes, one smelly person left in Smellyville. 11, the amount of pollutant measured in parts per million in Pine Lake can be modeled by the function there. Amount of pollutant as a function of time is 12, blah, blah, blah. It says you get extra points if you do this one by hand. I'm just going to strike that. Anyways, how long will it take for the amount of pollutant in Pine Lake to reach 4 parts per million? So it's 4 equals 12e to the negative 0.13 t. And feel free to y1 or y2 it. I'm not, because it's such an easy problem. Divide by 12. 4 over 12 is a third. I'm going to do a logarithm. It'll be a log base e, better known as an ln. So the natural log of a third is equal to negative 0.13 t. Divide through by negative 0.13, and you have your answer. And again, you do you, man. You want to go to y1, y2 with that thing, you go to y1, y2. There you go, 8.45 years. And then the pollution in that lake has gone down to 4 parts per million. All right, 10, find an inverse. Rules on inverse is step 1, swap x and y. Step 2, resolve for y. Step 3 would be profit, which is notation. So y becomes x becomes y. And then we isolate. Play the isolation game. We are going to subtract 12. X minus 12, could have swore I just changed color, is equal to 5e to the y minus 3. By the way, this is harder than the one on your test. Continue your isolation game. Divide by 5. X minus 12 over 5 is e to the y minus 3. And then we're going to convert to a logarithm. She shall be a log base e, whose argument is x minus 12 over 5, and it is equal to y minus 3. Add the 3. Remember that log base e is ln. And you are done. Easy peasy lemon squeezy. All right, number 9, your broke butt needs $1,100 to buy a used 1996 Ford Ranger. Sorry how your life worked out for you, but those things never die. Because of your lackluster work ethic and a 9200ths of a GPA, which caused you to drop out of high school, it was your math teacher's fault. P.S. You can't spell either. You work at Dollar Tree making minimum wage and have 0 credit. For some reason, the bank is still willing to loan you money, and they offer you a 5-year loan, 11.9% interest compounded monthly. Since you dropped out of high school, it is unlikely you will be able to solve this, but what will you owe the bank, and what will your monthly payment be? So anyways, this is your compound interest formula. The amount after time owed is the principal times 1 plus r over n raised to the nt, and you just feed this thing some money. The principal is given in text as $1,100. The rate of interest is 0.119. Don't get that wrong. We shift it twice, right, Abigail? Compounded monthly and is 12. And we are raising that to the NT 12 times 5-year loan. And then we go to our TI-84 and we push some buttons. 1,100. 1 plus 0.119, sitting pretty over a 12, with an exponent of 5 times 12, which happens to be 60. But again, if you don't know that, your calculator does not judge you, and I made a mistake pushing buttons. I see it. Good with that? You owe the bank almost $2,000 on an $1,100 truck. Anyways, you owe $1,988.50. So if you're making a minimum wage right now, you're making $7.50 an hour. Now, your monthly payment, it's a 5-year loan, 5 years is 60 months. So you divide that by 30. Divide that by 60, and there's your monthly payment. That's not bad, $33. That's really pretty good. I thought it'd be more than that. So, but that's what your broke butt can afford. And there's a good chance that it's probably going to get towed away too, because you're probably still somehow going to mess that up and not be able to make $33 a month. And they're still going to tow your truck. Anyways, graduate high school, please. So your monthly payment is $33.14 a month. I just thought it would be more than that. $33 when I say 14 cents. Hope you can afford it. All right, number 8, find the inverse of y equals log base 4 of x plus 2 minus a 4. So y becomes x becomes y, but you know this already because we've been doing this for quite some time. We're going to add 4, go to where I changed colors. X plus 4 is equal to a log base 4 of y plus 2. I don't have to divide or anything here. Base, argument, exponent. Logarithms and exponential functions are by definitions exponents of each other. This is why we do this. I should really make that a question on your test. Did you hear me? Logarithms are inverses of exponentials, and exponentials are inverses of logarithms. Anywho, there you go, kids. All right, so 7, I actually pulled this test from 2016. This is an old test. I've modified it a little bit for y'all, but it's an old test. And so it's got some things on there that are pretty ambitious. And I had to dumb it down for a couple years. We had Rona, all sorts of things going on, but y'all are doing really good. And I think you guys will have a pretty good success rate with number 3. You might. A couple of you are going to be entirely confused. It's just the way it is. But first off, let's do some simplification. 81 over 3 is 27. So we have a negative 27. Let's take a look at this. Remember the whole deal about shifting exponents? That's x to the 13th power. And it's all in the numerator. You have e to the 9th over e cubed. We subtract 9 minus 3 is e to the 6th. And we are taking a cubic root. Now, the cubic root of a negative 27 is negative 3, and I know some kids are bothered by that, but if you take a negative 3 and you multiply it by itself 3 times, you get negative 27. That's just what you get. So let's take a look at this x to the 13th part. X to the 13 is an x cubed, an x cubed, an x cubed, an x cubed, and an x to the first, because those numbers add to 13. Every single one of those x cubes creates an x on the outside. And that's going to be x to the 4th. Cubic root of e to the 6th is the next thing to analyze. That is the cubic root of e cubed times e cubed. And each one of them generates an e on the outside, and they actually are gone. And e is e squared. So negative 3x to the 4th e squared. Moving backwards, find the approximate value of the expression log base 5 of 240. It's asking what power of 5 creates 240, and that's a decimal. It's somewhere between 3 and 4. It's closer to 3. It's probably in the neighborhood of like 3.1 or something. I don't know. Anyways, I'm just going to do change of base. ln of 240 over ln 5, or if you like logs, you can do log 240 over log 5. You just do you. So ln 240 sitting pretty over ln 5 is, I was off, it's 3.4053. Evaluate log base 6 of 6 to the 7x, and it says by hand preferably. There is a way to do this with technology, and I'll show you because I've still got 18 minutes before I'm not getting paid anymore. This says, what power of 6 equals 6 to the 7x. In other words, it's saying 6 to something is 6 to the 7x. And the solution is obviously obvious. It's 7x. That's the answer. I'm trying to think how you do this by hand. If it was multiple choice, you could do it through some things. So let me show you what I mean by like that, if this is multiple choice. I'm going to put 7x in y1, and I'm going to use change of base to put that guy in y2. So let's just do log. We'd have log a calculator may not do this right because the exponent goes out front. We have 7x, and yeah, they don't. Also think of it about like this. Here's another way to think of this. Exponents go out front. 7x log base 6 of 6, which is 1. We spent some time on that. When the bases match the argument, it's just 7x. I don't even feel like trying to get that with technology, so scratch that out. Express the logarithm as a sum or a difference of logs. Express all powers as factors. Work is not required to be shown. I'm not. You should be able to get an answer. I don't know. But whatever, I'll break down all the nitty gritty. There's 1, 2, 3 things in here. We have a log base 4 of, I always felt that kids ought to be able to one-line most of these things. At least I did back then. I've kind of changed my ways moving forward. Plus log base 4 of z to the -3/4. Now, of course, I was dealing with a different breed of kid back in 2016. They hadn't been exposed to having a screen in front of them all the time. Exponents go out front. So we have 3/2 log base 4 of x minus 2 log base 4s of y minus 3/4 log base 4 of z. It's not a hard problem. Moving backwards again, solve for x. So it's been a minute since this has been taught to you, about a week probably. And I'm kind of curious how y'all do with it. You have a property that says a log of a times b is a log of a plus a log of b. So if I look at this from right to left, it's telling me I can multiply these arguments. I have a log base 8 of x plus 6 times x plus 4, and that's equal to 1. So before I move on to exponentiating, let's go ahead and FOIL. We'd have x squared plus 10x plus 24, and that's equal to 1. Now we're going to go through that process of exponentiating. When we exponentiate, this is our base, this is our argument, this is our exponent. 8 to the first is x squared plus 10x plus 24. We're going to subtract 8. X squared plus 10x plus 16 is now equal to 0. And this factors. Factors of 16 are 8 and 2, and they are the correct pair because 2 plus 8 is 10. So I get that x is -8 or x is -2. Now, the domain of a log says the argument is bigger than 0. If I feed that -8 there or there, it will be extraneous. And you had better be able to identify that. If I feed this -2 there, that's a 2, that's fine. If I feed it there, that's a 4, that's fine. This one is real. Almost done. Expresses a single logarithm. So we're going to do kind of backwards what we did on the last one. The very first thing we're going to do is we're going to move some stuff around. I'm not going to worry about the negative symbol. I'm just going to move the 2. This becomes the ln of x to the 2/3. Now, if a logarithm is positive, it's in the numerator. If it's negative, it's in the denominator. And condensed means from many into one, okay? So we've got an x to the 2/3 up top. We have another x to the 2/3 up top. In the bottom, we have a y squared because it is negative. And in the top, we have a y to the 9/2. So here's the challenge in this question. It's that you're having to work with these rational exponents. As I figure if you can work with these rational exponents, you can do it when the numbers are easy. So, you know, when you talk about x to the 2/3 times x to the 2/3, that is the x to the 2/3 plus 2/3. And 2/3 plus 2/3 is x to the 4/3. So there's a single logarithm that possesses x to the 4/3. Now, you talk about y to the 9/2 over y squared, okay? Your rule on this was x to the a over x to the b. You can do subtraction. In this case, we're going to do it's equal to 1 over x to the b minus, sorry, it's x to the a minus b. So we have y to the 9/2 minus a 2. Okay, 2 is 4 over 2. And that's y to the 5/2. And it was positive. Y to the 5/2. Complete reduction. There isn't even a denominator left in this example. I like it. I don't think it's bad. And finally, saved the first for last. Find the solution to the equation. Log base x of 216 is 2. So I have not asked y'all one of these yet so far in this section, but it's not that hard. Base, argument, exponent. X squared is 216. Not too bad, huh? Anyways, x is going to be plus or minus the square root of 216. And we're only going to be worried about the positive aspect. Although it doesn't really matter if you have a negative base or not, but we're only going to be worried about the positive aspect of 216. So 216 is an even number, and I'm going to run through a list of even things that might enter it that I can take square roots of. So my first question is 216 divisible by 4? Yes, it is. 4 times 54. I have a hunch I can do better than 4. So your even things you can take, your even squares are 4 followed by 16. Does 16 enter 216? No. But your next even square is 36. Does 36 enter 16? Yes, it does. 6 times. So the square root of 216 is the root of 36 times the root of 6. And the root of 36 is 6. 6 root 6 is my final frickin' answer. Now, in the context of this question, the negative would have been right too. No, it wouldn't have been because change of base wouldn't be valid. That's why I'm only worried about the plus. So why, it's a good question, wasn't I worried about the minus symbol? So if you did log base negative 6 root 6 of 216, and you try to do change of base on this, you'd kind of have a problem, wouldn't you? Like, this is not allowed. It's not allowed. It's not in the domain of a logarithm. So change of base fails. So not interested in the negative aspect there. Technically only has one answer. The other one is just garbage. To some degree, I guess we'd call it extraneous. That's what I'd call it. All right, there you go. There's your twin.